Okay, guys, we start the thesis of the dissertation for the Felipe Grings. First of all, I will thank for Professor Joao and Professor Righi for to spend the time for to read the dissertation, and it's very important for us the feedback and the suggestion for to improve the dissertation for by Felipe. And this defense has three parts. And the first part, Felipe showed your work. And Felipe, do you have 40 minutes for your presentation? And the second part, Professor Joao and Professor Righi is planned ask and discussion for your work. And the last and the third part, Lucio, Joao, and Professor Righi go in the other call for two discussion and deliberation your final results for acceptable or not. And go back to this room for dissemination, the final resolution. Okay. I thank you, Professor Lucio. Lucio help me and help Felipe and all step for the dissertation. Okay, thank you for all. Felipe, start. Do you have 40 minutes? 40 minutes for your presentation.
Okay, so good morning, you all. Can you confirm that you can see my slides?
Yeah.
Okay, awesome. So, as presented by Cristiano, I'm Felipe Grings. I will present my master title as NASP, Network Slice as a Service Platform Proposal for a New Generation's Network Beyond 5G. My advisor for this entire process was the Cristiano Bonato both, and my co-advisor was Lucio Rene Prade. It was a pleasure to start this presentation. So this presentation will follow the agenda, starting with the introduction, going to the background, the related work, the NASP architecture, the NASP prototype, the evaluation methodology, the results, conclusion, limitations, publications, and future work. If time permits, I have a demo to complete at the end of this presentation. So as introduction, 1 second, here. 5G brought us new paradigms about how to provide mobile networks. And one of them was the ability to provide mobile networks sliced as a service. And GSMA, that is the Global System for Mobile Communications Association, published this image that shows and represents the operation readiness level for each topic focusing to achieve the network slice as a service. And the topics was the static network slicing, the dynamic network slicing, and at the end, the network slicing as a service, where they show the state of the network slice as a service, achieving the orchestration of all three domains, that is core slicing, radio slicing, and transport slicing, going beyond 2024. So as motivation to this work and this master, I had to define computation and virtual resource of network slice based on the service level agreements and service level specification requests, link the end-to-end network slice by connecting and relating the three domains of the network, the core, radio, and transport, and automate management and orchestration during the life cycle of the end-to-end network slice. So the research question highlighted in this work was how to orchestrate and integrate the standardized components provided to provide network slice as a service that was described by 3GPP, ETSI, and GSMA. So as a hypothesis, I have that the orchestration and integration can be done from the definition of the interface for the relationship between the various components and domains distributing the network to relate all of the domains that we have to have a communication and a link between all the input and output for each domain, and to propose the hierarchy responsibility to define the area of operation of each function within the orchestrator. Oh, this request are disconnecting my mouse from the presentation. So moving to the background, network slicing is the concept for providing and running multiple logical customized networks on a standard shared infrastructure, complying with the GREES SLAs for different vertical industries customers and requested functionalities. So what we have here in this image is that the shared infrastructure that we have will provide two different slices. The slice one, where it's focused to provide high bandwidth for general purpose usage, and the second one using the same shared infrastructure, but will focus to provide high reliability and low latency requirements to autonomous driving and other uses. So keep going on the network slice. We can divide each domain in a specific group of slices independent of the components around. So we will have a bunch of radio slices that are not related with the group of transport slices. They can be related one-to-one and one-to multiple slices that we have for each domain. So going to the network slice as a service, network slice as a service is the ultimate goal that represents the service delivery model that allows the operators to provide custom and network slice to individual customers and eventually enables these customers to have access for some specific functions of this slice and management capabilities. So this is the default architecture presented by 3GPP, that we have the major functions, that is the communication management domain that will do the interface with the interface with the customers that will be managed by the providers. We have the NSMF, that is the network slice management function. Well, that will be the function that has the comprehension of the entire slice, considering the end-to-end over the three domains. And then we go one level above, that we will have the NSSMF, that is the network subslice management functions, that will be the management functions specific for each domain and subslice. So we will have one for each of them. That will be the radio subslice management function, the transport subslice management function, and the core subslice management function. And they will talk straight with the virtual and physical resource that we have allocated. So the network's life cycle, slice life cycle, it is important to understand that the first part, that it will be the preparation, the creation of a template that will be available for the users and the tenants to request the activation of this slice. Once we have the activation, we'll move to the closed loop of operation, that is the runtime, where we will be supervising it, reporting, and modifying if we have any problem in the agreed SLAs. When we move to the deactivation, we start a process to move to the decommission and termination. That is an important step, that in this part, the resource allocated can be reused for a new request to the slice. So the research was made in using three major knowledge base. That was IEEE, Scopus, and ACM. The query used for this research was 5G, 3GPP release 17, focusing on mobile telecommunication, next generation, and specific for more specific for core and service-based architectures, because it was important to use the 5G service-based architecture and the automations of CSM, network slice, or OSM. So the query started with the initial research of 3,750 papers found. I was removing the impurity, the duplicated, filtered by the title and abstract to make sure that all of them make sense to the subject that I was researching for, filtering the full text, and at the end, I had 21 papers that was actually useful for this presentation and this work. Now I could remove one label in my screen. So the related works were segregated in two parts. One of them was the projects running in the academy, that was the father of a lot of different papers. Projects like ONAP, OSM, OpenSlice, 5G Clarity, 5G Complete, and they were segregated in 6 columns. That was the characteristics. the first of them was if they were using 5G core SBA, because a lot of projects and papers were using the 4G or a mix between the 5G and 4G. I was looking for a specific 5G SBA. If they had a project model, how they describe the architecture, if they have a public architecture of the implementation of this paper and project, the service automation to provide the entire process without human intervention, the end-to-end service lifecycle management, if they could move from the running to the commission and reuse that slice using the platform and the proposed tools. And at the end, if they provide all of this using the fundamentals of network slice as a service. So it was set with a maturity level of low, medium, and high. And what they have in common is that all of them do not provide the entire process as service slice as a service, network slice as a service. So moving to the papers, I had papers from 2018 to 2024, where I use the same characteristic columns, and all of them still have this gap of network slice as a service. The papers most recent, like Wizikowski, that was from 2024, February of 2024, they started a discussion that we still have problems when we need to declare the structure of end-to-end network slices. And they had a more theoretical proposal on how to solve the problem from templates to instances. So what we have as a gap is that the state of art did not implement and orchestrate end-to-end network slice as a service over the radio, transport, and core networks. So moving to the NASP architecture. So as described by 3GPP and Etsy, are the main entities that talk about the architecture. We have the reference architectures, and NASP looks like an SMO when we compare to them. So the NASP will manage 3 physical and distributed different domains. That is the radio, transport, and core. So the NASP architecture has 4 major components. This is the high level of the architecture: the onboard, the orchestration, the quality assurance loops, and the interface to communicate with the controllers. So moving one by one, we have the design and the onboard. That is where the tenant request for a network slice. These requests are received as input in the onboard functionality that translate the request infrastructure resource following the case models that we have defined by GSMA and the attributes from NASP. So after specifying this use case, the onboard search for what we have of definitions for subslice templates that was already described by the operators in the catalog inventory databases to create an entire NST, that is the network slice template that will link all the 3 domains, different domains. As an output, we will have a definition that was the network slice template or network slice definition that will be an overview about the end-to-end of this network slice. So moreover, we have the network slice controllers in each domain, that is the R1, RN1, TN1, and CN1, that work together to provide end-to-end slice as a service. In example, the proposed resource allocation creates the association and interface required then to the end-to-end allocation. So we will have the request to activate this network slice template that will be received from the CSMF from the tenant. It will talk to the network slice management function that will have the overview about the entire slice, and it will talk for the specific functions, subslice functions, management functions, to them talk with the controllers that we have to manage the physical and virtual infrastructure. So this was important to set because the controllers can be different depending on the way that the provider set the infrastructure. In this case, and we will talk in the future, we will have the communication with the radio controller that is a Kubernetes core controller that is a Kubernetes 2, but we will have an example for transport controllers. We will have ONUS that is a different controller, SDN controller that could be anyone else. So this interface at the end will talk with the defined interface that 3GPP talks about. That is, in this case, RN1 will talk with the radio controller, that at the end will be E2 interface. Transport interface at the end will be a T1 because they do not talk about, so I was just assuming that it could be the same. And for core network, we have, after the controller communication, we have the OSMA, that is the interface defined. So at the end, we have the closed assurance loop. So the main function of the closed assurance loop is to relate to the execution time of the lifecycle of the network slice. So in this way, the quality assurance closed loop is responsible for monitoring, tracking, data analysis, and requesting actions to update the slice from a non-real-time point of view. So all these responsibilities refer to guaranteeing the SLS and SLA QoS that was defined in the network slice request. And in this context, the quality assurance loop has the 6 subfunctions that will be the telemetry to get the inputs from the slice that is running, the discovery to understand what is allocated for the specific slice, the data aggregation, the data translation to understand if that response time and latency makes sense when we compare to the SLA that we had, the service quality management to predict and impact the future impact analysis, and the AI model and training. So this part was not all implemented, but it was predicted in this architecture. But this master was focused more into how to enable and manage the end-to-end network slices. So this figure shows the hierarchy and responsibilities tree that is proposed by NASP architecture with 4 distinct tiers, outlines the decision-making structure of a network slice. So we have the first of them, the CSMF, that is the user interface communication with the platform. So we will receive a more business requirements level that it's not physical requirements and infrastructure requirements, that will talk with the network slice management function that will have a more technical view of the entire slice considering the end-to-end, and we'll start to translate the SLAs to resources that are actually functions and technical definitions. The tier 3 will be a more defined and a more future information, whereas the radio sub-slice management functions that will understand just about the radio. The transport will understand just about transport, the core about core networks, and all of them will report informations of this domain to the network slice management function that will have the end-to-end view and interact between all the domains and management the configurations that we need to create the communications. So at tier 4, we have the actual physical and virtual resource definitions. So in this case, like the core, how many functions we have, what is the resource that we have allocated for each functions, what the IPs that we have, and what is the inputs and outputs that this resource is using. For transport, we have the intent routes between our suites, and for radio, we have the RU, DU, and CU with the beans and more specific radio informations. So this figure shows the diagram with the sequence of events proposed by the system, initially from the TNN input that will talk with the CSMF, moving to the allocation that will go to the NSMF, and that relates with the hierarchy tree that I described before. So this is an important step that we have. The NSMF will first starting to communicate with the core, requesting an allocation of the instance in the core, because once that is done, core will return the inputs and outputs endpoints that we have for the core communication. So core will output the in example, the EMF IP, that is an information that NSMF will consider when requesting the radio allocation. So it will proceed preparing the templates to request the radio allocation instance, sending the EMF IP, that is then the input from GNODB to core. The radio will allocate the informations and will return the GNODB IP. So in this case, with the core instantiated and the radio instantiated, we have all the inputs and endpoints that we have for each domain, and it sub-slice instance. And at the end, the slice management function will prepare all of these things and request the transport network to allocate the links between all of the subslice instances that we have. So moving to the NASP prototype. The NASP prototype is a huge pool of technologies that we have. So starting at the top, we have the SMO, that is the NASP prototype. For the functions that I developed, I was using a mix of Go with Chin as HTTP library provider. I've used Python and Flask as well to provide the functionalities and the HTTP servers. All of the functions are running in the Kubernetes. It could be the same Kubernetes that is running the infrastructure. For database, I was using MongoDB. And for telemetry, I was using Istio, Prometheus, and Grafana to collect the data and to expose the data to any other functions that was required. In the infrastructure, for the core, we have FreeFive.gc running as the core functions, orchestrated by the Kubernetes. The Kubernetes was running over Ubuntu 20.04 machines, because it was specific for run with the GTP package that was only running in the 20.04. For the transport, I was using ONUS as SDN controller over a Mininet simulated infrastructure to create a topology. And for the radio, I was using the simulated My5G run tester running over the Kubernetes too. So the network transport topology. The transport topology was designed over the Mininet and managed by the ONUS to simulate the real-world scenario described later in the presentation. The topology followed the idea to have two different roads. So as we can see, the S1 to S2 from S2 to S3 and from S3 to S1. In this case, I could set two different roads to provide different requirements and different resource for each of them. In this case, one of them would follow the low latency requirements, and the other one will follow the high bandwidth requirements. So to create these rules over the Kubernetes pods and namespace to Mininet and relate the road to the NSI, I use IP table rules created during the slice activation time to forward every Linux container namespace that is different from Kubernetes container namespace to a virtual IP over the Mininet that was linked to switch ports. So the virtual IPs were related to the switch ports, and some intent rules in the ONUS were associated to link from switch port 1 to switch port 2 that was redirecting, in example, VLAN 1 to S1 port 1 that will forward to S1 port 2 that will link to S2 port 1 and going on as well. So that will be described with the VLANs creating these routes from the input in the radio that will catch the rules that I have for the specific slice, complete the entire road, and at the end have the same informations overridden by IP table rules and move to the core function. And one road for low latency and the other one for high bandwidth. So NSST directory tree. So this is the definitions that we have for the domains, the NSST definitions that we have for each domain. So radio and core use Helm charts with predefined structure, while the transport is a little bit different and it uses a structure of list for creating the NSSTs that at the end will be the intent roads. So this figure shows the full files that we have for Helm charts, like the chart YAML, the README, the notes. But the templates also show the template also have the files that will outline the NSST configurations and details for Kubernetes. So in this case, it is a tree for EMF configuration that is on tier 4 that I talked before. So here we have the EMF high availability, the EMF service, load balancing, and configurations for Kubernetes, but we also have the values and config.yaml files that are files that contain the specific slice informations that NASP will understand and modify in the activation time. So this will be prepared to have the specific informations working in the slice 1, slice 2, slice 3. So as the config.yaml in example has informations like MCC, MNC, and MCSI. So here are the templates examples that we have. So the first one is the GSMA template with some attributes proposed by NASP. So in this case, we have the GSMA attributes, that's availability, SS key, package delay budget, max flow bitrate, downlink, and all of the others. But we have some NASP specific attributes, that is the type of resource, the resource, the type, if they are shared, if they are not, if they provide non-3GPP features or they don't. So you have more business information in the GSMA templates. So when we move to the NSST definitions, we start to understand a little bit more about the overview and technical overview about the end-to-end network slice, where we have the resource descriptions. That is, in this case, if the core, which functions we will have in the core, like AMF, NRF. In the transport, we will use the backhaul, the front haul, the backhaul and the front haul, and these definitions of physical and virtual resource that we are using in this network slice. And at the end, we have the NSST detail definitions. That is the specific for each domain. So in this case, the RAM, which function are we using, which type of that is, how many replicas do we have, what is the MCC, MNC, what is the ID length, the link IP, the AMF configs address, and all of this other, the slice informations, and all the others. And at the end, we have the last one, that is the tier 4, that is the Kubernetes informations, like in this case, the Kubernetes information. So what is the amount of computational resource that we have for that specific function. So evaluation methodology. So in this master, it was considered 5 evaluation metrics. The first one was the instantiation time of an end-to-end network slice. The second, the scalability of the platform and the slice that it was providing. Third, flexibility and customization of slice requests, cost efficiency, and UA connection latency. So description of the cloud instance that was used. I had 3 types: internal, metropolitan, and central. They are used in, the data was collected by AWS and replicated in the mininet running on DigitalOcean. So in this case, the internal we can relate to edge instance, the metropolitan to fog instance, and the central to the usual cloud that we know. In this case, we have some metrics like in a instance that we have 4 vCPU and 64 gigabytes of RAM, the price will be $526 a month. Metropolitan will be $181 a month, and the cloud will be $137 a month. The description latency, so the instance were allocated in different places: Ashburn, Miami, Philadelphia, and Atlanta. And these were the average latency collected by 2 days running in a row. From Miami to Atlanta, the average latency was 24.8, standard deviation 4. And the others were similar. It will make more sense in the next slides. So this were the topology simulated on mininet and collected the data from real environment. So we have the short path that was talking about the ultra reliability, low latency, was from Miami to Ashburn with a latency of 24.8. And the other one is from Miami to Atlanta, and Atlanta to Philadelphia, and Philadelphia to Ashburn. That is a long road that I was considering as a high bandwidth, but a little bit more slow when we compare to the short road, the short path. So evaluation methodology, I had 2 study cases. That was the 3GPP run and the non-3GPP. There was different implementations. So the case of 3GPP is that we have the 3 domains working all together. So we will have some shared functions, some specific functions for that slice. The transport will have different NSSIs, and we will have the radio NSSIs too. In this image, what I want to show is that each subslice instance is a specific template that will have described in the platform, and it will be considering with the inputs and outputs from the NSSI1 to NSSI2, from 2 to 3 and 3 to 4. So the 3GPP or run case that I was using is considering the core with the other functions, transport using the backhaul, and the radio using the virtualized my 5G run tester. And the difference from to the non-3GPP is that the non-3GPP doesn't have the radio part. So it will stop at the transport, and transport, it will be the input part, the access point that we have for our slice. In this case, we will be running a different function that will be considered the input, that will be the entry IFF. So slice deployment scenarios. With the 2 case, I created 4 slice scenarios. That first one was MIOT, that has no shared functions. All the functions were specific for that slice. No functions running on the edge. All of them was on cloud, and using the long road path. Ultra reliability, low latency, was considering all specific functions. Some functions in the edge, like UPF, EMF, SMF, that are the most important functions for admissions. The other functions were running in the cloud using the short path with low latency. The shared, where it was using all of the functions as a shared scenario and a shared infrastructure, sharing with other slice, but the admission functions were specific for that slice, all of them running on cloud using the long path, non-3GPP, all specific slice, specific functions with the entry IFF, no non-function in the edge, all in the cloud with the long path. So starting the results. The first result that I had is the slice deployment time for different scenarios. So what I was trying to understand here with this result is when I have different deployments, functions, and different deployment resource, do I have different deployment times and time for availability of the slice? So these metrics were collected and segregated in 5 parts. That is the NASP design, the time to the NASP understand the request, prepare the templates, and request from the to the domains, the core deployment, radio deployment time, transport deployment time, and slice activation at the end when we have all the link together, the time for the slice to the functions to communicate themselves and discover themselves. So what we can see here is that even when we have less functions to deploy, like the non-3GPP, the time is almost the same. But when we use a shared function, a shared scenario, we have a significant less time of deployment because we already have a bunch of functions that are running in our infrastructure. So we don't need to instantiate the functions and wait to them be available. We can just select the functions that we want to add to the slice and use the functions that are already running and modify them. Oh, let me go back. And here we have a significant different time. Here we have 22 seconds to deploy a shared function, a shared scenario, when we compare to the other scenarios that we have around 53 seconds to deploy that. Slice deployment step by time. So here's to understand what are we allocating of resource and why we take so long as 53 seconds to deploy that. So the first steps to create the informations about the end-to-end network slice. So here we have highlighted the core deployment, the radio deployment time, and the transport deployment time. Core deployment time was taking a long time when we compare to the others. Basically for 2 reasons. The first one is the proposed way to deploy the functions that I have in this architecture, that is considering one function. Each function is a specific template, and we can manage each function separated from the others in the way that are orchestrating in the Kubernetes. So the problem here is that we have a bunch of way more communications with the infrastructure when we're trying to deploy each function. The radio is simulated, so it's very fast because it is simulated. But the transport is very fast too, even when we use ONUS as controller and Mininet. So here we have a usage of almost 50% of the deployment time in the core. So if we have time in the future, the focus will be to decrease the deployment time in the core and to move the radio deployment to a real scenario. So network functions deployment and reconfigurations. So this chart aims to show one thing. We have three different scenarios from the four: the MIOT, URLCT, and non-3GPP, that we cannot reconfigure. So if we see here, if we already have these scenarios running and we want to deploy a new one, all of them has no reconfiguration options. But when we compare to the shared function, shared scenario, we are able to reuse the functions that is already allocated when we move from the decommission, the deactivation to decommission part of the life cycle, and we are and we release those functions that are not in use anymore, and a new request, new slice request, is activated. So the shared functions can grab these functions, just reconfigure some specific points, and reuse without reallocating the entire function. It will just reconfigure those specific functions. So this is the point that I was trying to show here, that if we use scenarios that are not shared, we always need to deploy an entire slice again when we want a new slice. But when we use the shared scenario, we can just grab the functions that is already running and prepare them to land this new slice that is being requested. So here what we have is that if we try to deploy 10 slice, to try to reconfigure 10 slice in the shared scenario, we will need 50 reconfigurations. But when we try to reconfigure the other scenarios, we can. But if we try to create a new deployment in the shared, we will need to have all of them will need to have an amount of deployments. So moving to the next one, UE connection time for different scenarios. Here we have what I was trying to understand here is if I put the function admission functions in the edge, it will be faster or don't. So what I have here is that for the ultra reliability, low latency, this is a little bit darker, but it is a way faster because I have all of the most important functions in the admission in the edge, so the communication will be very fast, and my data plane will be created very fast. We have the MIOT and N3GPP similar times, and we have the ultra reliability, the shared with long times, because the functions are distributed and the latencies are highest when we try to communicate internally in the functions, the core functions. So availability of network slice, we have a comparison when we use NASP orchestration that can handle the load balancing and the shutdown of different functions. We can compare a reconfiguration using the load balancer function from NASP to other functions. When we go to start the reconfiguration, if we don't use the orchestration, the slice will have a time down, and if we use the NASP orchestration, we will use the load balancing redirecting to other functions that are available. So latency and reconfiguration process, here we have the latency to connect to create a data plane with user tuner request. So if we use the NASP orchestration, we will have a latency around 750 as latency to create the tunnel. And if we don't use that, we will have a timeout during the reconfiguration that will break the availability of the slice to create new user data planes. So adaptability of network slice. Here we have NASP understanding when a slice reach the maximum of one of the attributes requested on the SLS, and creating a new slice to land these new users that are being requested to create the tunnels. So we have a limit of 7 users connected to the slice 1. When it reaches, the NASP start the reconfigurations to put available a new slice that will receive the new user tunnels connections in the slice 2. So RAM and CPU usage over time. So here we have the overall infrastructure. I don't know how I am in the time, but here we have the overall infrastructure, RAM and CPU usage when we try to request new five slice requests, 10 at the total, but 5 to 5. And here we shows that when we request the 5 slices, we have a plateau time that will the configuration time, but when those slices are available, we start a 40 user requests the tunnel creations for a minute. The usage of run and CPU will start to increase. When the 5 slices are completely deployed, we have the other plateau that will be requested a new 5 request slice that will have this, again, the plateau from creating the configurations. And when it starts to be available for the users to actually create the data planes, the core and CPU the CPU and RAM start to increase again until it reaches the new plateau with the 40 users per slice per minute. And we have 10 slices in this case. So here we'll talk about the price when we run the Edge, Metropolitan, and Central using the same scenario. And what we have here is that when we move to, well, the results show that an exponential increase the cost deploying the network slice in the cloud when we compare those 3 environments, with the cost starting with $91 in the cloud and $192 in the edge. And when we move to the 5 slice deployed, we move from $91 to $106 in the cloud and $192 to $230 in the edge. So the analysis revealed a significant cost difference with an increase from 109 to 116 for 5 and 10 slice respectively when we compare with the cloud deployment from the edge costs. So conclusion. The evaluation proposed by 5G mobile network drives digital transformation in different segments of society, and we have a lack of guidelines to provision real-time network slice as a service. So the research question was how to orchestrate and integrate the standardized components to provide the network slice as a service. And going further in the hypothesis, we have the techniques. We will need techniques to translate business templates to technical instance definitions from the GSMA SLS to the resource definitions, a combination of templates to create NSI and establish a link among all of the domains to create end-to-end network slice configuration, and automation and management strategies to request flow to enable the instantiation and ongoing management of slices. So what we achieve here is that with this proposed platform and architecture, we could provide 3GPP and non-3GPP cases with 4 different scenarios, proving the platform adaptability. So we could, using this hierarchy and tree definitions and interface definitions, a platform adaptability to provide different slices. A 66% of NSI creation was core dedicated configurations, 93% of reduction in data session established time compared to when we use the ultra reliability low latency to the shared scenario, and 102% cost variation when we move from 5 to 10 slice creations over edge and central environments infrastructures. So the contributions, it was able to design and develop the network slice as a service platform to allocate, activate, and deallocate slices instance in the runtime, design and development of integration between 3 major mobile networks institutions to merge all the required definitions to create end-to-end integrated architecture, because they have a lot of different gaps between the technical documents that the entities provide, translate the GSMA business level templates to NST and NST templates, and develop an end-to-end slice allocation to non-3GPP applications that is a gap in the literature. So limitations that I had in this work. It was using an emulated run. So a lot of information that I had in the data plane are blocked by this limitation. The data plane that I was trying to stress had a bottleneck of 40 megabytes of bandwidth, and I had a lack of stability over the GTP 5G package that was really difficult to had stress test over time, because this package for some reason just broke and the platform stopped working because it cannot provide new slices. So publications, I had 2 publications during this time. One of them was in the Globecon, that is CCA1, with the title of Full Dynamic Orchestration in 5G Core Network Slicing over the Cloud Platform. And the other one was in a Brazilian conference, that is the Simpósio Brasileiro de Redes de Computadores e Sistemas Distribuídos, SBRT. And 2 publications that was co-author in Brazilian conference too. So as future works, the NASP platform now is a tool that is being used in a plateau, that is a project in the Open Run at Brazil from Brazil 6G and from RMP. Thank you. I don't know if I have time for the demo because it was long.
Okay, Felipe, thank you very much for your presentation. Felipe has one demonstration, but don't have more time. And now we started the second step for the fees, and we invite Professor João. Is more far away for Professor Righi. And thank you, João. Thank you again for to accept and collaboration in our work. Thank you for your explanation, and let's go for your discussion and contribution.
Perfect. Before anything, Cristiano, how much time do we have for this section?
Don't have a time now. Do you have the free time for your considerations?
Amazing. So first of all, I thank you, Felipe, for presentation, for thesis, for this amazing work, and also to Cristiano for inviting me to be part of this banca de defesa. You got me. I don't know how to call this in English, but anyway. But then again, I think I'd like to start thanking and appreciating Felipe's work. I think he did like an incredible job, both in terms of what he was able to accomplish in terms of implementation and his results, but also his research output. They're all commendable, right? I do have a bunch of questions and things that some things I could not really understand or think would require a bit more like polishing in terms of writing, explaining some motivations among other things, right? So I do have a list of questions. Starting, can we actually go to maybe the thesis, right? The PDF, because I have a bunch of comments kind of that go like chronologically, like with your thesis. So if you wouldn't mind
sure,
opening the PDF.
One second, I'll be right. Yes, here. Can you
Perfect.
see it?
Yeah. Can maybe like go to page 22? Yeah, so I think early on, writing introduction, both in the thesis and your presentation, you talk about that one of the motivations for NASP is the whole thing about not only integrating different network segments, right, within 3GPP, but also with non-3GPP networks. Could you please motivate why would you want that?
Sorry, the audio is a little bit cracking. I could not hear the 3GPP and non-3GPP, and what was the question?
Sorry. Can you motivate why would a mobile network operator want to interface with a non-3GPP access network?
Oh, okay. Yeah, sure. The access to non-3GPP will open a lot of ports to have a network slice over the operator's infrastructure. So sometimes we want to have infrastructures connecting to the operators that locally will be some Wi-Fi connections that will go to the mobile networks in the transport and the core. But sometimes we want to have something like one of the papers I can use one of the papers that was published using some drones. So we want to create a slice to provide a mobile network to, at the point, the user equipment being drones that will not follow the specific requirements that we have for smartphones connecting to the network operator slice. Sometimes we will have drones connecting to it. Sometimes we will have Wi-Fi. So the idea to provide the slice over the non-3GPP is to open the possibilities that we have to be available to this slicing feature. That is one of the goals that we have at the 5G and 6G. So that's it. At the end, we want to open the possibilities to other type of networks to connect to these features.
No, this is super cool. No, thanks for the explanation. And if I can already like start leaving comments, I would say that your answer was perfect, but this should be captured in the thesis, right? It's kind of motivation to us to why would you want that aside from just being, let's also incorporate non-GPP, but why, right? Cool. So maybe next page. So during your thesis, right, you talked a lot about NSIs and SSIs, domains, subdomains, subslices, right? So I became a little bit confused with your terminology, right? So can you explain what's the difference between a domain and a subdomain?
Yeah, sure. I have one slide. I have this image here, I guess. Let me go deeper here. Nope. Maybe the slide will be better to explain, I guess. Let me just see if I have it here. No, yeah. Okay, the slide will be better. Let me open it. So this is a good image to explain the difference between network slice template and network slice instance and a network subslice instance. So the network slice instance and template is the overview about the 3 domains that we have. And each domain could have more than one subslice instance. In this case, we have for the radio, I'll get specific for the radio and after for transport. The radio will be a domain that will have 2 different subslice instances in this case. The first one will be the RU and DU that will be all together, and the input and outputs will be beyond this communications because they are not segregated in this infrastructure. The RU and DU will communicate to the CU that will be segregated in this infrastructure, in this template, and the CU will be the other part because we can set, since they are different components and different resource that we can allocate, we will be able to manage them individually. So we'll have specific definitions for that resource that will be the CU, and those in different definitions for the other resource that will be the RU plus DU. So between them, since once I will have the specific definitions for each of them, since they are distributed, and the other part is that between them, I will have a part of the transport in this case. So the first subslice instance in the domain radio, in this case, will be the RU plus DU. The second one will be the CU. And the transport will have 2 subslice instances again. The first one will be the mid haul, and the second one will be the back haul. So since I have this break between the resource that I have, so radio will talk with network instance. This network instance will talk with the radio instance, with the network instance, and move on to the core. 3GPP defines that the subslice instance are the smaller parts that we can manage all together. So if I have different functions that will be managed individually, this is one network subslice instance, and they are related to the domain above that.
Okay, no, that's perfect. And thanks for the explanation. But so once again, I think we need to be very careful with your terminology, right? Because not only have domains, subdomains. At some point, you also have subnets and subslices. And again, also you also have in different locations throughout your thesis, you have network slices, whereas in other places you call them by end-to-end network slices, which makes it very confusing to follow, right? So it's just either having a table early on or some other way to clearly delineate the differences between those different things, because quickly it makes the reader get lost about what you mean by those things.
Yeah, I completely understand that.
No, thank you for your answer. Could you go down to like page 28? Or because I think it's the first page where you the core the core architecture, right? So again, during your presentation and your use cases, and also earlier on during your conversation, you talked a lot about the non-HTTP interworking and writing to interacting with Wi-Fi and UAVs and so on and so forth. However, this feels like an important part of your motivation and part of your story, right? The story you're telling. But when you're now showing us all the core functions, an example, right, of how the 5G core works, you haven't illustrated or included the non-3GPP interworking function, the N3IWF, in your core. And that feels like something important is missing. And beyond that, again, this is more like a comment rather than like a question, right? Beyond that, you haven't defined in the entire thesis what that function does, what's its purpose, how it integrates with the 5G core, what's supposed to do, right? I think you only use it then later on, like maybe in chapters 5 or 6, but without ever explaining how it works. And if this indeed is something important as part of motivation in your very story, this needs to be introduced early on, like there, more or less. Can you go down to page 30, please? I think when you start talking about SLAs and SLSs, right? And about the consumers of these slices. And one thing that wasn't clear, and I want to ask you, right? What do you think in this context would be the consumers of the network slices? Of the NASP platform, right? Who would be your consumers?
Okay, yeah, that will be more clear in the demo that I didn't have time to show, but I can explain it. The NASP platform is focused to be consumed by the providers, where the providers will prepare the network templates, and they will be the managers of the platform, and they will provide the slice templates as network slice as a service to the user, so the verticals in this case. So in the demo, I could show the two different views that I have inside the platform. One of them is the operators, that will be the managers, that they can create network slice templates. They can create network definitions to how many type of catalogs that we have, what our infrastructure are capable of doing. And when you move to the tenant view, that is the verticals, the industries, you will have a view that is, okay, I have one slice that is focused on MIoT. I have one slice definition that is focused on low latency. And you can select those slices and request them to be created, sending your information to connect to them. So the slice will be created in runtime and will be available. So in this case, you will receive the access points, and you will be able, as a vertical and a tenant, to connect to this slice that was created by the platform.
Okay, well, thank you. And once again, this is the kind of thing, even though it was supposed to be part of the demo, right? I think that your thesis should exist as itself, right? As an archival piece, and all the information you need to understand and comprehend your contributions should be therein. So again, the tiny answer is please explain what you mean by this. I think a little bit like maybe in page 36, we're sort of defining like your structure to evaluate different related works. You talk about different types of orchestration schemes, right? And you define a partial and a total network slice orchestration schemes, right? Could you explain what are their differences?
Okay. Yeah. So there's definitions of partial orchestration and oh, I forgot. I lost the partial and total orchestration. Was proposed by me and the team in the paper that was published in the Globecon. And the most important part is that the partial was able to manipulate. Let me step back. 3GPP and the entities declare 3 different steps to achieve the network slice. The first one was the statical, dynamic, and the network slice as a service when we achieved that. So a lot of papers were declaring that they achieved the dynamic network slicing that was able to manipulate the slices in runtime without dropping the entire infrastructure. But the problem was that even when they were doing that, the slice was having a downtime when we try to access from a user endpoint perspective. So we defined the partial and dynamic and total dynamic orchestration. That was 2 different parts inside the dynamic orchestration. That partial was you are able to create a slicing runtime, but yours and modify the slicing runtime, but the slice will have a downtime. And the total, you will be able to modify the slicing real and runtime, but you will have some load balancing strategies and availability strategies to not have this downtime when you have the slice running, and the users will not feel that downtime. So that was the 2 different between the partial and total inside the dynamic. So you are already able to manipulate the slices in runtime, but the partial you will still have a downtime, a short downtime, and the total you don't have the downtime.
Thank you. No, that's perfect. I think the next page, right on next page, when you're like finishing talking about existing platforms and like what we have been doing, right? I think one of the key arguments that you make to motivate the development of NASP, right, is when you say that existing works, right, they don't consider the network slice functionalities of the 5G core, nor the slice models defined by the GSMA to assist managing these network slices. Quote. So I want to ask you, right, what specific functionality of the 5G core regarding network slicing should be considered, and why?
Sorry, I lost. What the 5G core function should be considered for?
No, so okay, in a different way. So I think when you're talking about this related works, you talked a lot about Mono and OSM and the things they've been doing, right? And you state that they're great, they're wonderful, they do amazing things, but they don't consider functionalities of the 5G core. That's exactly what you wrote there. They don't consider functionality of 5G core, nor slice models or whatever. So that's why I want to ask you, right? What functionality of the 5G core should be considered and why? What particular aspects of 5G core make the different functions different than normal Kubernetes clusters or whatever?
Yeah, so what I was trying to talk here is that a lot of papers was using the 4G core and 5G core, but in a mix and not the service-based architecture. The paradigm that was break between the 4G and 5G core SPA was the SPA, the service-based architecture, where we break the core in a lot of different functions. That in this way we move the telecommunications to a computing view of how to orchestrate and manipulate that. So in this case, we receive a lot of we gain a lot of possibilities of high availability, and the main one that I was talking is about the high availability, because I can manage the admission. In this case, there are some specific functions and explore that a lot. You have when I have a stress in admission, I can just scale. That was the word. I can just scale the admission part of the core, and when I have other stress, I can scale the specific parts of the 5G core. So this possibility to manage the core as microservice and have the interface between the among the core as HTTP APIs, it gave us more possibilities to escalate, to orchestrate, and to get information from it. So that was the major part I was talking why I wanted them to use the 5G core, because of this characteristics that I just talked. When we move to the 4G core or the mix of 5G with 4G, we don't have that possibility to orchestrate them as microservice. So we lost a lot about the how can we. Other thing that I forgot to talk is if I want to reconfigure a function, I don't need to reconfigure the entire core. I can just reconfigure the specific functions that will be using the slice identifiers and the slice the slice attributes. Does it make sense?
Yeah, it makes a lot of sense, and again, it goes really much in line with what you had in your presentation, right? But again, I'll just ask you if you can to revisit this in the text, just to make sure this explanation in the text match what you presented and what you just discussed, right? Just to prevent any confusion. But your explanation is perfect. Moving down a little bit, maybe to page 48, if you don't mind.
48?
Yeah.
Yeah, here.
Yeah, so yeah, perfect. You talk about this slice descriptor, right? And how it contains different types of attributes, right? From GSMA, 3GP slice, 3GP network attributes, right? But one thing I don't remember finding in your thesis is what are the differences between those different types of attributes? Could you please talk a little bit about how they differ from one another?
The attributes from GSMA, you mean?
Yeah, if you scroll down, yeah, there's a list of 3 attributes down there.
Oh,
yeah.
Here? Okay, yeah. So let me remember this part. That was a long time ago. But basically the GSMA template attributes, they were more focused on SLAs and SLS. So we had one of the tables that I showed before were talking specifically about it. So we had definitions about what is the latency, the download bandwidth, the upload bandwidth, the UE connections, UE, I forgot the name, the entire presentation, UE tunnel PDU establishments. That was the word that I forgot the entire presentation. The PDU sessions. And so 3GPP slice attributes, they talk more about the infrastructure that we have. So 3GPP talks about it will have the NSSIs that we were talking about, how they will integrate radio with transport and core. And yeah, 3GPP, when the slice attributes and network attributes, they were talking more about this two things, about the infrastructure, how we will provide the infrastructure in a template. And GSMA talks more about what we need to provide in a business perspective view. So that was the merge that I had between them to provide one template that makes sense, talking about the business and the infrastructure. Okay, thank you. Perfect. If you can go to the next page, please. You have I think figure 7. Yeah. Where you show like your 2 different types of slices, right? The local connection, different functions, the things they share, right? Great. I actually really honestly, I really like your figures and diagrams. They're really polished. They're great. But one thing I want to ask you, right, about this particular figure is about the 2 types of slices, right? Because they share the DU and the RU, right? And then I want to ask you, would those different service classes be treated the same way in the RU and DU? Sorry, what's the difference between?
So even though those 2 service classes, right, the mobile broadband and MIoT, right, the 2 service classes, even though they share the RU and DU functions, right, would their traffic be treated the same in those functions? Okay, that's a good question, because the part of the radio is the part that I didn't touch so much. I just used the My5G run tester when I was reading and creating the background. I went a little bit delve deeper in what they had in the RU and DU, but I'm not aware of what is the difference inside the radio that they have to provide this difference.
slice classes. So one thing I know that is the some attributes that I was using in the My5G run tester, that is the simulator, are just parameters about the PDU sessions and how I will forward that. But the low level about the RU and DU and TU, I don't know. That's the point. that is part of the project that is going on in the future works. That is the plateau that aims to move NASP to orchestrate the radio in this type of details, to orchestrate the RU, DU, and TU. That is the future work.
Well, that's perfect. And what I think could be either way. You could say yes or no, like there's no right answer. I mean, there is, but anyway, it depends on how we're going to do things. I really think this limitation there should be acknowledged in terms of what the NASP does and does not, exactly at this point, and make it clear to the reader that you're not going to touch this part there. I've noted at the end of the end of your thesis, in your conclusions, you do mention some of the limitations, but I think right there would be the perfect spot to first mention this limitation. And then again, like at the end, remind the reader of whatever you talked before. But since you talked about the My5G run tester, spoilers, I was going to go into this afterwards. I want to ask you, what is this? Because you haven't explained what this guy is, like in the entire thesis. You say use this guy, but not what it is, where to find, or any of that. I know I could have Googled this, but I didn't want to Google this just because I wanted just to find answers in your thesis, and I couldn't. So please, enlighten me. What is the guy?
Okay, yeah. That was a point because at the end of the master development, I had to feed the My5G run tester because that was the tool that I was used to use. Because the entire idea was to use the Open 5G as a radio simulator and to have the RU, DU, and TU more detailed inside the orchestration. But at the end, the time didn't permit, and I had to use the My5G run tester. So the My5G run tester is a radio simulator that was developed by Cristiano teams from from student in the science computing graduation that completed as a final work. So it is a simulator from the radio that will generate the GNODB and the entire connections that we have, the entire message processing that we have to communicate with the core. So 3GPP defines a lot of communication sequence that we have to connect a run, to connect a UE, to have a PDU session establishment, to have the load balancing between AMF, to understand that if this AMF is not available, we can set to the other one. So 3GPP defines a lot of this, and the My5G run tester was a project to implement all of these communications and to simulate the radio access in a way that we can connect a virtual GNODB to the core. We can create user equipments, and we can stress the radio, stress the infrastructure over creating PDU sessions. It was more focused on stress the control plane, but at the end, using some iPerf and other data plane stress tests, it was able to stress the data plane too. And then we got the bottleneck of 40 megabytes per second. But that was this is a simulator developed by our team, and it aims to have the sequence flow of message and connections to have a virtual GNODB connecting to the infrastructure, and then we can validate the entire process of connecting a user equipment, creating the session, the PDU, the interfaces, and stressing the infrastructure.
Cool. No, that's super cool. And but then again, so I think you mentioned something really important, that this was a home-brewed tool, right, that your group developed. It's not something like widely available, like OAI, SRS, or ONOS, right?
Yeah, actually it is.
No, sure, public available GitHub, sure. What I mean to say is not that famous or widely known to anyone working the field. So that being the case, I really think you should add a couple of sentences explaining what this guy is, and add maybe a reference or like the URL so that you can direct people to find more information about the super cool project, super cool tool that's out there, but may not be actually known by most people. But thank you for the explanation. Like now, based on what you said, everything does make sense. Cool. Can you move to the next page, please? Page 50. Yes, perfect. That diagram there. That looks super interesting. But I want to ask you, right? So it's how are the components, right, of your end-to-end network slice deployed? Are they deployed in series or parallel?
Series.
And why?
Because yeah, so that was a problem that I had when I was developing the prototype, and that was one of the decisions that impact a lot about the core deployment time. Long story short, I was trying to have more control about the functions that I had, first of all, in the core. So to deploy that, I had to break each function in a specific Helm chart, and I could not deploy all of them simultaneously altogether because because I had this problem about a sequence that I need to let them be available, because the first of one need to be R and F that will be available, and after that I'll instantiate EMF that will connect to it, R and F. And if I try to deploy EMF before having the database of discovery, the functions do not work so well. So that was the first part, and it was all of the functions were in a specific Helm chart that was deploying all together, but if this short specific series. But the problem is that to modify one function, I had to modify the entire Helm chart and to redeploy the entire Helm chart, and that was not good. So I created the series deployment to have more control about the core functions. And why I had that was specific for core. And about the core radio and transport, I had this series because when I finished the deployment on core, I will receive the access point to the gnode B access the core. So once the core is allocated, I will have the access point that will be the EMF IP, and then the NASP will modify the template to the radio, already setting the IP to connect the GNODB to the core. So I could do that after it is deployed, but it will be a little bit trickier. So in that case, I set in series deployment, because I set the deployment with all the configurations already prepared, and I didn't have to modify the radio informations in runtime. And after that, after I had the two access points from core to radio, I create the links between to do not have to modify the intent roles after they are already published and active, to not modify them in runtime. So in that case, I prepared all the informations that I have in core. That core has no dependency. With the core informations, I complete the radio dependency, that is the access point for the EMF. When I complete the radio, I have all the informations that I have that are dependencies for the transport to create the link between the infrastructure. So that's why it is a transport. It is a series.
So everything you said is amazing. It's exactly like a nugget of information, knowledge, and know-how, the lessons learned after working in this for like years, right? And that exact information is what I think would be super valuable to meet the thesis. And not even like in terms of limitations, right? But like based on the procedures and protocols and how the core functions work, you need this kind of control, you need this information. And the conclusion of this is you require a serious deployment kind of thing, right? And this, I think, would be amazing, so that it would be amazing if you could explain this in the text, so people could, like me, would say, yo, this is serious, why? No, there's a reason, a fundamental reason that led to this through trial and error, right? You tried things until they work, and you came to this conclusion. So this exact thing is super valuable, and would be great if you could include this knowledge in the thesis. But also talking about this diagram, one other thing I want to ask you is how when and where is like the radio coverage calculated? Because if you're asking those different base stations, they could be in different locations. How would you know where to place them? Is it something that NASP considers, or is that a limitation?
No. Yeah, so that's a limitation. I'm not considering the geolocation deployment for the radio. We have in the same group, Cristiano have a different student that published a excellent paper about this, that in the future maybe could be put all together, but in this case, the NASP is just considering how to create this link between the end-to-end network slice, and not considering the allocation, the regional allocation of the radio and the resource. It was static for all the scenarios.
Cool, amazing. Thank you. Can you go now down to page 53, if you don't mind? Yes. So yeah, I think that's the point where oh, sorry, maybe page 52. I apologize. Where I have that figure 10. Yeah, when we first talk about this AI component, and it wasn't clear. Honestly, it wasn't clear in the presentation. Sorry, in your thesis, but it was later in the presentation where I made it evident that the AI piece isn't part of NAS, but something that you're considering as important part of the architecture. And again, it would be great that if the thesis could also carry this this information. But so even though you're not looking to this, right? How would you envision this AI model and training in the future being incorporated as part of NASP?
Okay. Yeah, that's a good question. So for now, what I have is just for small metrics that I collected as how many PDU sessions were established and what is the frequency that I closing and starting the connections. So for the AI training and the AR specific features in this project, we have a 3GPP definition about one function that is the NWDAF, if I'm not sure. That is the function specific for collecting the data and exposing to AI trainings. So it has a lot of open ports, and a lot of the papers that I was reading is considering this part and focusing about the AI trainings. So some of the topics that I can relate in top of my mind is that considering about stress tests, if we have any patterns about how the network will be stressed, about allocation of resource. So one of them that is I'm requesting a new slice, where it should be allocated. So it will be in the edge, it will be more resource in the edge. How many computational resource I will allocate for that specific slice? Because one of the things that I didn't made in a deeper level was get this information from the business level. Like I need a bandwidth of 1 GB per second per slice and 2000 PDU sessions established, and admission of, I don't know, 20 seconds. All of this information can be more prepared if we have an AI training of how the old network slice were working with the infrastructure that we have, and when we receive a new network slice, how we will organize the infrastructure considering the data that we had in the past to provide better resource and better result with the SLA and SLS that we have.
Cool. No, that's amazing. Thank you. I think I'm talking too much, so just going to try to speed up myself a little bit. Can you please go to page 56, figure 11, where you have get the mapping between open source solutions and the overall NASP architecture. This is just a comment, not a question, right? But I think it is interesting to see the complexity of the problem and different bits and pieces that you can already, let's say, leverage from the community and the open source, whatever. But what I don't see there is like what I really would think would go a long way to demonstrate the complexity and the challenge and the part of the contributions would be a different diagram showing the interfaces, the communication interfaces, the components that you could use out of the box, like vanilla, or things you had to modify, different middleware or plugins or translation layers you have to implement, like the thing you mentioned about ONOS and the third way of like whatever establishing routes that you have to develop yourself. Those are not shown there, right? So I think we've had a separate diagram that kind of goes deeper in detail, saying, oh, between block A and B, we have to create this guy, or whatever, new blocks you have to develop, and use, let's say, code coloring to explain what you develop, modify, and include it. That would be great. That would be really cool. And again, sorry if I'm speeding up. We're running out of time. But can you please go? What am I going to go next? Oh yeah, can you please go to page 68, please?
Yeah, here.
Yeah. So there, in the like first beginning of the paragraph, right, for 3GPP Aura, you say you are going to evaluate Aura to explore the complete 3GPP 5G network stack. So that being said, that exact sentence there, I want to ask you, what's the relationship between 3GPP and Aura?
Oh, okay, yeah. So ORAN is the alliance for radio access networks. So they will have. Let me think how to explain that relation. So 3GPP is one of the entities that talk more about the slicing, an overview about end-to-end. So when we start to read the technical files, technical descriptions about 3GPP, we can see architectures and reference like NASP for SMO. So a lot of my architecture was based on 3GPP technical files, technical documents, and they will specify more details about what is the domains, what is the responsibilities about the domains, what is an instance inside the domains, and we will have this open view about the entire infrastructure and the entire service that we want to provide, or run specifically for the part of run. So radio is very complex inside all of this mobile network thing that we are studying. So I almost can give a half and a half of responsibilities to developing the infrastructure and the management about the entire orchestration, and the other part that we can delve deeper is the part of ORAN and how to break this RU, DU, CU. That is another project. But what I can relate is that with the definitions of 3GPP, the hierarchy tree that I've proposed, the sequence that I've proposed, it is already able to start communicating with the ORAN definitions that we have that are deep, more technical for the radio access. Not sure if it's making sense, but what I want to talk is that one of the things that I was talking is about manipulating the slicing in runtime, but not real time. They are non-real-time manipulations that I'm doing. When we move to the ORAN specifications, we will start to talk about the real-time modifications that we are doing. So they are linked subjects, but we will talk in a different level of I forgot the word about how to say it, but we will talk. They have the link between I will need to orchestrate the entire slice to start orchestrating the radio access, and I will have the non-real time over 3GPP and the real time manipulation over ORAN. Does it make sense?
Okay. Sort of, kind of, maybe. So, and again, I understand that you're not a radio person, not that was your focus, right? But by far and large, you're looking at this from a more holistic end-to-end orchestration point of view, right? I could, as a radio guy myself, I could let this slip because your answer is partially correct. There's GGP doing all the things, core, transport, run, whatnot, and then the ORun goes on top of that, literally on top of that as a plugin, only for the run part, right? And you have had and you have production networks out there working nicely with run slices and bunch of parts and whatnot with 3GP alone. So you can, and you have 5G networks out there without ORun whatsoever. So ORun is not a requirement for 3GP, nor is it a requirement to have it running, nor is it a requirement to have any kind of experiment in mobile networks whatsoever, right? So again, I would really ask you to revisit your argument and how you motivated the use of ORun as part of experiment, right? Because again, you do not need ORun to have a complete 3GPP 5G network stack, right? And I just want to be very clear and be very careful, so you don't have like an objectively wrong statement in your thesis, especially when you're something so important as to motivate why you went for this kind of design pattern or this evaluation. Just want to say this.
Okay.
But thank you. Okay, can you please go to page 72 when you start talking about results and like things get fun. You have, I think for figure 19, yeah, you have this breakdown, right, of the different components for like the delay for deploying your slices. And one thing that I thought was like very interesting is that your 3GPP and non-3GPP run slice setup times were basically the same. You even state that in the text when you're discussing results. So I want to ask you, what was your run slice setup process for both the 3GPP and non-3GPP use cases, and why you think their deployment times were so similar?
So the major difference between the non-3GPP and the 3GPP scenarios that was deploying is that one of them at the end will the 3GPP at the end will deploy the radio component that in this case will be just the My5G Run Testers simulator. So I was basically changing one function to another. The 3GPP scenarios will deploy the radio part of it, that will be the My5G Run Tester, and then on 3GPP will abstract that and deploy the N3IWF function to be the access point of the entire scenario. So that's why they were very similar in the deployment time, because I was removing one function and adding another function that since I was using Kubernetes and all the same environment to deploy the functions, they had a very similar time of deployment.
Okay, no, thanks. Okay, but I think this kind of opens up more questions than answers, because again, they could go into, okay, but how is the My5G Run Tester doing things and the time it takes to do whatever, right? Yeah, so I probably would try to either look into just in this, because the time it takes to like bring up base stations and UEs and whatever, it's very, very different than it takes to set up a Wi-Fi router, right? So those results to me are like, could be valid, sure, but I think would require further investigation to explain why it's exactly that, and I hope it's just not like changing function pointers and whatnot. So maybe try to stress this or flag this some way that is probably due to like the way that 5G run tester works, something like this suggestion. Okay, but thank you for your answer. Can we go now to page 81 in your conclusions?
Yeah.
This is again more a comment, right, than a question per se. But again, I think in your presentation and the conversation we had so far, you did an amazing job explaining your motivation, re-articulating your research question, right? So even here, so if possible, like you to propagate what just presented and like what's back in the conclusion, back to the introduction, even if that would potentially require you to further elaborate or slightly tweak your research question than it already is, because it's right now it's perfect. In introduction, I don't know, it doesn't feel like you did like such a good job, or that it wasn't, let's say, concrete enough. Whereas here, I think there's a lot more meat, or okay, by reading the conclusion, I can say, okay, that's what he wanted to do, that's exactly that, that's what he accomplished, perfect. kind of thing. But another thing in the conclusion, in page 83, when you talk about your limitations, you mentioned something quite funny that you also referred to during your presentation when you talked about facing certain instability. Could you tell us more about that?
The GTP 5G package?
Yes, because you said like you couldn't run the NASP for like many hours, like the break. What was happening there?
That was a very stressful thing that until now I don't know what was happening, but every time I had to make a workaround to have it fixing and working for for a major time. But the problem was that I was trying to have some data for, I don't know, a week running and stressing the test, connecting and disconnecting PDU sessions to see how the entire infrastructure will work in this situation. But the problem was that for some reason, and I don't know why, the GTP 5G just stopped working, and my UPF could not use the library and the package inside the Linux, and I start receiving an error. And the only way that I had to solve the problem, I didn't went deeper in this to understand how the package was made. I was just using the package, was to restart the machine, uninstall the package, reinstall the package, and then it will be able to connect again the new UPFs. But that was a problem because since I was creating and deleting a lot of slices in these tests, when this problem occurs in one of the nodes, all the UPF that was pointing to that node will not be able to receive any PDU session. So my long-term test just stopped working because the PDU session started to be deleted, and no one new PDU session started to be created because I had this problem on UPF.
So again, this is super cool, right? And again, this kind of nugget of information, knowledge that would be super important to anyone else ever, I don't know, trying to deploy NASP or creating something similar or working a similar problem, right? Would probably end up facing similar situations, just like the thing you discussed earlier on, right? About the serial deployment or of your end-to-end network slices, right? So, and then I wonder, again, just a suggestion.
Mm-hmm.
Those two things sound super important, and again serve as lessons learned as an outcome of your masters. And I wonder if it wouldn't make sense to have, I don't know, a subsection at the end of prototype or whatever, or talk about evaluation, implementation, where we have these two things explaining lessons learned, things we discovered throughout the process, because those would be very valuable to anyone reading your thesis, trying to reproduce your experiments, because they would face the same things, and they probably would spend weeks trying to figure out what happened until, oh, there you go, a paragraph, explain, yeah, fine, I know what to do, kind of thing, or why things are happening. So if I can leave a suggestion, will be that, because again, that sounds super interesting. Yeah, cool. And one last thing, right, last but not least, after your masters, right, after your whole ordeal, all this implementation work, your results, all your papers, after the whole process, right, with all the experience you gained and the lessons you've learned throughout your masters, right, would you have done anything differently, right, in different design choices and different direction? Would you have done anything differently?
Yeah. Probably I had two things that I was thinking about that was not so good. One of them was the I could not implement the open air interface RU, CU, and DU things that I could really try to install that. That was one of the goals in the beginning of the master, and I was not able to understand at time all the functions that was provided by the entity. So that was my goal, to deploy that and not just my 5G run tester simulator. Other thing was related to the way that the platform is working right now, because it was, I cannot show the demo. Maybe I can show at the end, but just for information. But it was very tricky to have about more in a user experience, to have this creation of the NSI and how to relay the NSI inside the platforms. the NST, so how I was dealing with the data inside the platform, that was not so well developed in this case, and what was part of the operator and what was part of the team, and that was like a workaround to have all of the things working. The APIs at the end were more well designed, but in part of the platform itself, in the user interface, that was not good. And this tricky part that I talked about, how I was doing the Helm deployments, that influenced a lot about the core deployments. That was, in that time, that was the best solution that I found to have the manipulation for each specific functions. But that increased a lot the deployment time of the core network. And that's not good, because when I compare to the um, first plan that I had that was deployed, the entire core, prepared the entire Helm shard inside NASP, and then deploy one Helm shard, that reduced the deployment time of the core to 10 seconds. And now I have 20 something 30 seconds deployment in the core time. So those are things I gain a lot about doing this in this way, but I lost about the time that I have to deployment and how the platform to understand. It gave me a lot of complexity inside the NASP to understand all the functions, because in this case I didn't have just one Helm chart to manipulate inside the Kubernetes. I had 20 Helm charts that I had to manipulate one by one. I had a lot of repetitive code configurations, informations inside all of this. So these parts are things that maybe in the future can be better. But one part that was really good was in a rush too, but that was really good, was about the ONUS SDN controller and the integration with NASP and ONUS. At the end, that worked pretty well. That was good to have that results at the end.
Wonderful, Felipe. Thank you so much for, again, your work, your thesis, your presentation, and for this conversation. I really appreciate it. And yeah, so Cristiano, I think it will be all from my side.
Okay, thank you, João. Thank you very much for your feedback and the suggestion and the questions. I don't know. We are 2 hours in this call. I don't know. It's we go out or stop for one break for so for example, bathroom and the other time. What do you prefer? The minutes or not? Or to one break for go to the bathroom?
I'm on you.
Okay, I suggest we stop for 3 minutes, 5 minutes, or no more, for go to the bathroom and go back in 2 or 4 minutes. Okay.
Agreed.
Hello, Felipe.
Hey, I'm back.
Go back, guys. Thank you for this break. It's important for the health. Professor Righi, we continue and feel free for discussion, asking Felipe for contribution in his work. Thank you again.
Thank you very much, Professor Cristiano. Well, that we are in front of a very nice work. Congratulations, Felipe, in advance, right? So I don't have much questions here, right? But I have, two or three. And well, most of all, I have sentence to show you some points that could be improved in order to improve the quality of the master thesis at the end, right? So it's important to improve your motivation. Well, in the introduction, it's important to present clearly where related work is failing, right? So well, I have this thematic and I have this problem. So considering this problem, that's a not new problem, for example, but I have, well, two or three main related works. And well, they try to solve the problem, but still we have an open problem. And considering this open problem, I have my work, right? So it's important to present this cut clearly. So the other issue that I have here is considering the database, because I work with high performance computing and I work with distributed systems architecture, right? And well, the selection of the database, it's very important. The first decision is regarding SQL or no SQL, right? And basically, this decision is impacted by data consistency. For example, banks use SQL because consistency is very important for them. So it's important to talk, to express in detail in the thesis, because you selected MongoDB, right? So MongoDB is a very nice database, and MongoDB is a document-oriented database. So, for example, MongoDB performs very nice with JSON documents, for example. But, well, considering the NoSQL type, we have also Cassandra database, we have also InfluxDB database, and considering the SQL schema, we have Postgres, right? So Postgres, but Postgres is very simple, Professor Righi. But, well, Postgres, we have a plugin for Postgres named Timescale. And so we have a very nice performance with Postgres with this plugin, right? So it's important to write your main rationale behind the selection of the database, right? Well, going ahead, well, I'd like to ask you about a bottleneck, right? So you are presenting an architecture with a lot of modules, right? And while considering your additions in the state of the art, do you have a bottleneck? For example, this and that model could be a bottleneck in the future. For example, could be important or pertinent to work with a load balancing close to it. Or, for example, I can work with cloud elasticity in order to enlarge the number of instances at runtime. So please talk a little bit about bottlenecks in your models.
Okay. So that's an interesting topic, because that goes in the same direction that the partial and the total dynamic orchestration. One of the things that I've realized in the beginning of the master was that reconfigurations in runtime was a huge bottleneck that we had in the core 5G core services. And to provide that, had a lot of different, in that time actually doesn't exist a lot of projects trying to solve that problem, but had a lot of open calls starting discussing this problem. And that was the subject of the GlobalCon paper that we published. That was exactly in this point, how to create and define an SCTP load balancer using the characteristics of our infrastructure that we had in that time, running with the Kubernetes and the free 5GC core that was the core that we were using that time. So the first paper that we published, we made a SCTP load balancer because Kubernetes were not working so well when we tried to use that in specifically for the EMF function, and we had to increase the number of slices that specific EMF were supporting in the infrastructure. So the first one, we developed an STP load balancer to it because that was not working pretty well, and we were trying to manually escalate the EMFs to have some, because they were not exactly the same with just replicas inside the Kubernetes. They were a little bit different from each other because we have some slice IDs definitions that were different from the first one to the second one. So that was the first part of that was the start of this project and this master. So after that, we understood how to integrate with the Kubernetes to create these load balancers to provide the high availability, and how we will need to deploy the EMFs using the blue-green deployment strategies, or creating different EMFs with different name, different set of components, but linking to the same load balancer. So that was a tricky part of the prototype development. So at the end, one of the problems that I faced is that when I try to escalate a lot the infrastructure that I have, I still have problems because the load balancer for SCTP do not work so well when we escalate to 100 EMFs or something that is higher than what we expect. So this is one of the bottlenecks that we have. The load balancer that I was using, that was the Kubernetes load balancer specifically for SCTP. With in this case, I changed it a lot, but the last one was Calico as the CNI, the container network interface. It has some problems when we escalate to a higher level of functions for a specific slice in this case.
And so all this history, in my viewpoint, is very important for the master thesis, right? Please, it's very important to tell all the history, considering the bottleneck, considering the load balancing, and so on. So going ahead here, I have, well, not a question, but an issue considering orchestration, because orchestration is a buzzword, right? So orchestration could be a lot of things. So it's important to understand what type of orchestration are you doing. Let me show you an example. I could work with APIs, and I am connecting APIs. The output of a particular API is the input of the another, and so on. That's a possibility, right? Or I am working with components, right? And so I can glue the components. Or I am queuing a lot of layers. That's other possibility of orchestration, right? So it's important to put in a clear way, okay, in my viewpoint, the orchestration idea, I am following this and that authors, right? And orchestration for me is this, because the concept of orchestration is so vague, and it's important to put your context here, right? Going ahead, well, you have a predictive engine, right? So considering that you have a predictive engine, predictive quality of service management model, right? It's important also to elucidate what algorithms are you using and why. For example, we have machine learning oriented algorithms with neural networks, or also we have more simpler one considering ARIMA and SARIMA and so on, right? So it's important to see or this kind of algorithms is good for me because, well, it can solve this particular problem and so on, or it fits nice to my problem, right? Because predictive is another buzzword, right? So we have a lot of possibilities to solve the keyword predictive. It's important to, okay, in my viewpoint, The idea of predictive is this, and also considering the keyword predictive always when working with prediction, we have a lot of items in the past, right? And you have a prediction engine, and you are presenting a forecast in the future, right? So it's important to understand how many elements are you taking into account in the past and how many elements are you considering to forecast in the future, right? So please elucidate this in the final document. So going ahead, always, not always, but well, sometimes, often, right? When working with resource monitoring, we have a period. So I will collect the CPU load, for example, the network latency at each 5 seconds or at each 1 minute, right? Of course, you can adapt this period on runtime, at runtime, sorry, right? But it's important to present your rationale behind the selected period. In my thesis, we are adopting, for example, the period of 1 minute because in our context, well, these and that authors are also following this period, right? So I work with resource monitoring, and the selection of the period is very important because if I have a period so short, right, I have a lot of intrusivity in my application running, and in the other side, if I have a period so large, I have a loss of reactivity. So it's important to understand what's the best period for you. So going ahead, right? Well, you are using cloud computing, and well, you are using virtualized resources, and well, you have a topology that's very nice and doing your tests, right? But it's very important to know that cloud computing, and especially Amazon, we sometimes we cannot guarantee a particular latency or a particular CPU power for me. Please talk a little bit about this, considering the guarantees. Are there some options in the cloud that you have selected in order, okay, I should have this latency or I should have this CPU power, especially for me because we are working in the last analysis with virtualized resources, right?
Yeah.
Please go ahead.
Yeah, so this is a question that I was expecting. So that was one of the things that were out of the scope in the NASP, because that was a point that at the start we were discussing a lot, and for this project it was not able to understand and to select this type of resource to guarantee the SLAs, because at the beginning I started the proposal talking about 1 year ago, trying to propose how to guarantee the SLAs that I will have 1 millisecond of latency. I will have 4,000 PDU sessions with downloading in XBit or something like that. And then I start to move to this problem that I'm in cloud. I can't even guarantee that I will have that resource that I'm allocating in the cloud. So I cannot guarantee what I'm using above that. So that was a problem. I tried to have a local server to discover and understand a little bit more, but I was virtualizing stuff inside this server, and that was a problem. So this was one of the stuff that was out of the scope inside this master, because I tried to focus more on how to create the links and the architecture to have the workflow on deploying end-to-end network slice. But that is a very good topic.
Yeah, so Felipe, maybe you can add some words in the limitation, right? So at the end of the document, so you have a section that I love, limitations, but it's important to see in this and that situation, my work does not perform well, right? So there you can write some words regarding these topics. So going ahead, I have here 4 or 5 topics to conclude, right?
Yeah, just to complete that.
Go ahead.
Yeah, just to complete that question, I moved from the local server to the cloud in that specific point because I started to think that if I consider that cloud is limitless resources, I can have something like when I move to that, I will have a third-party guarantee that the SLAs will be more accurate. So that was the defense that I had in this part of that all of the infrastructure was deployed in cloud, and that was not part of the NASP guarantee, the resources, but the cloud have more control over the high level requirements that I had. Just to finish the topic.
So perfect. So nice answer. Well, it's important to elucidate if is there a benchmark in your area, for example, or well, we don't have a benchmark, a common user benchmark in my area. Considering this, I am creating my own benchmark, right? So I have this doubt, and well, also considering the evaluation, it's important to emphasize how did you create your evaluation scenarios? Are they relevant for the literature? For example, I guess yes, right? But it's important. Okay, I am creating this and that scenarios following that author again or following that author. And well, in the future, I can compare my work against related work because I am following the main adopted scenarios. So this author also evaluated his or her work with the scenario, so I can compare qualitatively, at least, right, my work against theirs. So going ahead, well, considering another very important topic, statistics, right? So could you talk a little bit regarding statistics? How many runs did you do for the final graphs, for example? So I am doing an average, or I have a confidence interval, or I did a single run, right? So explain this, please.
Okay. Yeah. Some of the tests had more runs and some of other don't. So an example, the first chart that I've presented, that is the average deployment time for each scenario. I had a script that was running around 200 deployments for each scenario. So using this, I get the average and cut the limits, and that was how I got the I forgot, that's not limits, the outbounds above normal curve. And that was the data that I used to present in that chart. The second chart, that is the step-by-step, that was just a few runs to understand the step. That was not a huge load of runs to get the average of each one, because that was a little bit hard. It was 15 runs to get the average of each step using the same process. And let me remember. Most all of them was in this structure of collecting the data. I had some scripts that run. I collected the data, create a normal curve, cut the out boundaries of this normal curve, and presented the median and the average of the values that I've got. For some of them it was more, and for some of them it was less. Some of them I could automate with the average connection, the PDU establishment, PDU session establishment. That was a good one to automate. So I could do the 200 runs, and each run was doing a 40 connections, PDU session connections. So it had 200 x 440. So this one I had a lot of data to analyze, but others like the step-by-step and the average CPU and RAM usage, they were running less because they were more tricky to prepare the automations to collect the data.
Yeah, well, in my viewpoint, again, it's important to bring these details to the final document, right? So how many runs and why on each case and so on.
Yeah.
So finally, I have not a question for you, but it's important to put this in the final document that the thematic is more general, right? The idea is technology transfer, right? So how to transform your research into a final product, right? So how can I use your research in mobile providers, for example? So I have an idea about this, right? Because you have showed these ideas about technology transfer, but complementary, it's important to present how your research can add quality of life for any citizens in a city, for example. So I am a citizen in São Leopoldo, Rio Grande do Sul, for example, and how can I get some benefits regarding your research? That's important to present 2 or 3 phrases in the conclusion, for example, regarding the benefits for end users, right? So that's all for my case. Again, congratulations, Felipe. You have a very nice work, right? So congratulations to you and to your advisors, right? That's this for my case, right? And I am very happy for this invitation, and I am very happy on participating on this jury, right? That's all, Professor Cristiano.
Thank you, Professor Righi. Thank you very much. It's a great collaboration and to improve the Felipe work. It's very important for we receive the feedback, the comments, and the questions. It's very important for us. And now I open any question for the public and Lucio and other peoples in the room. Please, one question, comments.
No, only thanks.
You're the best, man. We love you. Yay!
Go ahead, Lucy.
Congrats, baby. Love you.
Okay, guys. And now, Professor João, Professor Lucio, and Professor Righi go in other meeting to discussion and deliberate the approve or not approve the thesis. And more, I don't know exactly, but in more 5 and 10 minutes we go back in this room. Okay, thank you.
Perfect.
Não, tu sabe o que é o pior? Eu ia sugerir, quando eu tava olhando para trabalho, tu fazer uma tabela para explicar aqueles slice disso, slice daquilo, porque eu mesmo não entendi porcaria nenhuma, né? E aí eu pensei, não, eu não entendi porque eu não sou da área, né? Mas daí o cara lá falou que talvez você devia ter feito uma tabela, né?
É que é muito complicado entender esses negócios. É muito chato, assim. Eu demorei muito tempo para começar a entender, e para quem bate o olho a primeira vez é um caos.
Mas eu pensei em fazer uma tabela de abreviações, sabe? Tipo,
Sim.
porque fica
Na
mais...
verdade tem, né? Na verdade tem a tabela de abreviações, só que ela não é reexplicada durante o texto.
Exato. E talvez uns comentários. É que por isso que eu não te falei para fazer isso, porque eu mesmo não entendo nada, né? Daí, tipo assim, com tabela, sem tabela, botando tabela, tu desenhando, eu também não entenderia. Então, para mim, não fez preço, mas eu vi que ele falou.
Sim.
Eu queimei meu almoço, tá?
Foi adiante, no fim das contas, eu não consegui nem apresentar a demonstração.
Não, eu queimei de botar fogo mesmo.
Meu Deus.
Tô considerando jogar a panela fora.
Já tomei 5 copos de água, 2 xícaras de café.
É só...
No fim, eu vi que um dos meus colegas do trabalho entrou, mas já saiu.
Falou bem, querido. Gostei. O inglês estava em dia. Trocaria 1 ou 2 palavras, com certeza, mas estava em dia.
Tu viu que eu prestei atenção até nos Among.
Ah, não, os Among, gente. Eu tava cuidando o tempo inteiro para ouvir um between e jogar na tua cara, mas não teve.
No fim, eu acho que deu mais tempo ainda, né? Eu tinha que ter falado em 40, eu acho que deu 40 e tantos ainda. Isso que não deu a demo.
Não, mas é que atrasou um pouquinho, eu acho que tu fez em 43 pelos meus cálculos.
Só que eu tinha mais 5 minutos, no mínimo 5, para apresentar a demo.
Aí não rolou.
Aí complicou a vida. Eu quero publicar essa apresentação depois. Publicar no YouTube da vida, mas daí eu corto e boto.
Foi tu que pediu pra ser em inglês por causa disso?
Por vários motivos, né? Porque um dos professores, ele é brasileiro, mas ele tá nos Estados Unidos. Isso aqui vai ser... Eu depois vou replicar pros meus colegas do trabalho.
Sim.
É mais fácil de vender em inglês, né?
Não, sim, com certeza. É
Tipo,
o marketing.
eu vi que em algum momento a Ariel entrou. E aí, se fosse em português, ela não teria entrado.
Ah, sim. É mais inclusivo. Quer dizer, não é mais inclusivo, né? Mas. Quer dizer, é e não é, né? Mas assim, é que pra mim foi indiferente, porque se fosse inglês, português, espanhol, francês, eu não entenderia nada igual, né? Eu tava comentando com a Marla, tipo, eu tô entendendo todas as palavras, mas pra mim é um monte de palavras aleatórias numa frase.
E juntas não fazem o menor sentido, né?
Exatamente.
Vou até fechar minha câmera aqui e me espreguiçar um pouco.
Eu vou ver o que eu vou fazer com a panela.
Me lembrem de tirar uma foto depois. Não sair da chamada sem tirar foto. Um print da tela com todo mundo.
E eu talvez fique devendo essa parte, porque dependendo do horário eu vou ter que vazar, porque eu tenho que trabalhar.
Tranquilo. Eu esqueci do meu TCC agora. A ideia é ter pelo menos a do mestrado.
Vou me esforçar.
Tudo bem, Felipe?
Tudo certo. Acho que não tem mais
Momento
mais
de
ninguém fora
compreensão
aqui.
aí.
Dá para
Enfim, vou
migrar para
deixar
português.
teu orientador conduzir aí.
Okay, I continue. João. We lost João.
There.
Okay. Now the bank is full. Okay, Felipe, the discussion is very far and the conclusion is unanimous, and you approve in your master degree the master dissertations, and you now one master. But we need to receive the feedbacks for the Professor Joao and Professor Righi and change and improve your final document. I look and advise you in this last phase, and do you have 60 days for submit the final version for the UNISINOS. And congratulations, did you work, the other work is very, very good and a great job. Thank you and congratulations.
Thank you very much, Joao.
Congratulations, Felipe. That's a very nice moment. Wow. So all the best for you, for your family, right? So congratulations again to your advisors. It was a pleasure and thank you very much. See you. All the best.
Thank you. One time, I just want to take a screenshot that I've never took when I completed my graduation. I want to do that now that it's a master. How can I do that? Oh, I think that's good to just take like this. So 1, 2, 3, cheese. Now, thank you guys. Thank you very much. Thank you for your time and patience.
Thank you for the message. Thank you all. Bye-bye. Good lunch.